Okay, in this problem, you're going to take on the role of a trigonometry teacher. Now it's your job to correct a proof that a student has given you. And in this proof, I'm going to tell you, there's a mistake in there. Maybe there's two mistakes, okay? But the proof is somehow flawed, and it's up to you to find the error. So the purpose of this exercise is to take you through the process of checking very carefully what's happening from one step to the next, and not only do you need to be able to justify it, like, is that the correct step to take next? But you also need to be able to look for errors. That means you need to know quotient identities, reciprocal identities, Pythagorean identities, and just basic algebra, right? Check those plus and minus signs and everything. So here we go. We're going to start on the left side of this proof, which I think is a good place to start because it's ugly. And we always like to start with the side that is the ugliest. So we're going to start there, and I want to talk about this step right here. Step number 1. Is that a correct step? Or are there some errors in it? Well, if you look above it, you see that we're going to need to FOIL. We're going to need to distribute the multiplication. I'm going to start with tangent times 1, which is tangent. Okay, no problem there. Tangent times cosine. Okay, negative cosine. So that's negative tangent cosine. Great. Down here, I've got sine times 1. Looks good. And sine times negative cosine. Good. Okay, so first step is just fine. That means we will not select that. Remember, we're selecting errors. Select any steps of the proof which contain errors. So that means if it's correct, you just leave it alone. Moving on to the next step. I've turned tangent into sine cosine. That seems fine, right? That's the quotient identity there. Tangent times cosine. Okay, in that one, I've changed tangent to sine over cosine again. So far, so good. No problems. And the rest of the step 2 was unchanged, so I think step 2 is just fine. No problems with these guys. Step 3, okay, sine over cosine was unchanged. Look at this. We get negative sine over cosine times cosine equals negative sine. Well, that makes sense to me. I think this is a step where we're just canceling out those cosines. So that looks good. Sine doesn't change. And, oh, this is interesting. What is this student doing here? Negative sine times cosine equals negative sine squared. Nah, I don't think so. That's a mistake right there. So step number 3 has an error in it. And now we have to keep on going and say, was it just step 3 that had the error, or is step 4 flawed also? So as you look at step 4, can we get there from step 2? Well, sine over cosine, sine over cosine. Okay, that looks good. Now this step right here, negative, what is that? That's negative sine plus sine. So those are going to cancel out. And that matches, right? We don't see those terms in step number 4. And then we get to this last one, minus sine cosine, and we've got minus sine cosine. So somehow this student just made a mistake in step 3, but then step 4 was fine. And sometimes things like that happen when you're a trigonometric proof teacher and students are trying to bamboozle you, right? They'll try to just wave over some steps because they don't know how they made the mistake, but they know where they're trying to go, and they just sort of try to cover over the difference. So now moving on to step 5. Is this allowed? See, it's not sine over cosine that's changing. It's sine cos, which is changing to sine cos squared over cos. And I think what the student here is doing is changing to common denominators by multiplying. Let me get that check out of the way. I think what they're doing is multiplying by a cosine theta over a cosine theta, which is a good idea, honestly. That's not only allowed, that's a good idea. So step 4 looked good, step 5 looks good. And now what? Well, as we combine these two fractions, we're adding them together. We've gone from sine minus sine cosine squared to sine plus sine cosine squared. Okay, that is maybe an innocent mistake of getting the plus and minus sign wrong. So I think step number 6 has an error in it. And in the next steps, we look at this like, what's going on here? That looks like a GCF to me. Okay, we factored out a sine. And then in this next one, 1 minus cosine squared changed to sine squared. Okay, that's quite nice. That is a Pythagorean identity, and that is just fine. And then what's left? Sine over cosine changed to tangent, and that's fine. That is a quotient identity. So every single step in this proof is justified, except for steps 3 and 6.